Hello, everybody. I am Casey Meyer, and today I'm going to be talking about working with the OpenAlex Snapshot. Um, Here's a little bit about me. I went to UC Davis in California, really into Python, Flask, Django. I'm from Iowa. I currently live in Omaha, Nebraska. I had the pleasure of flying on some of these airplanes pictured there in the Air Force. I like shooting pool, playing Rocket League, and doing things that aren't programming on the weekend, occasionally like camping. Here's the agenda, what we're going to talk about today. I'm going to tell you about the snapshot, how to get the snapshot and download it, how to ingest it to a database to do two different types of databases, how to keep your snapshot up to date after you've ingested everything. And then we'll go over some frequently asked questions and things that we see support tickets about so that, we'll give some tips and tricks. So about the snapshot, it's a full export of the OpenAlex data set with a public domain license. So it means it's completely free to use however you like. It's exported straight from the OpenAlex API. So we actually have an open source script available. You can see how the API is exported. I mean, this snapshot is made, and it's from the API, and that like we ingest all of our data into Elasticsearch, and that's what serves the API. And when we create the snapshot, we just call Elasticsearch to get all the data. So what you see when there should be very little difference between the API and what's in the snapshot. And it's hosted for free via the AWS Open Data Program. So that's really cool in that we were able to allow people to download all the data from AWS. We don't incur those high bandwidth charges you would normally have with a project of this size and the data of this size. So how can you get the snapshot? Really, there's two ways. You can browse this link I'm showing right here at the top. And it's really nice because you can browse the entire snapshot. And if you click on these files, you can also download parts of the snapshot and check it out. So you don't have to use the other ways. You can just go here and get parts of the data, or it's not a very good way to get all the data, but it's a good way to see like the manifest or different ways to work with the data in what an easy to use browser. Then the real way you probably want to use it to when you actually need a big part of the snapshot or the whole snapshot is use the S3 command, which is listed there. It's really you're just getting that whole bucket and trying to save it to somewhere on your local server or computer or whatever you're working with. The thing at the end there, you have to add this no sign request. That's because normally when you use AWS, you're logged in and it's looking for credentials. And that's kind of a way to say that you don't need credentials to get this data because it's publicly available. The snapshot is produced every 3 months for all users and every 1 month for premium users. Now, this is kind of change we made a little while ago. And right now, you can still technically get every month, but we're moving to set something up where it's going to be more of like the public version will be updated every 3 months. One moment, please. And then you can see the documents, documentation is right there. There's a lot of different documentation about the snapshot there. I'm trying to simplify some things here because it goes pretty in depth. But yeah, check out the docs because it kind of just gives you these same instructions on how you can download it, how you can work with it, but in a more technical way. So what's inside the snapshot? Really what you get, we'll show on the next slide, is every entity like authors, sources, works, has its own folder, and then there's folders within each entity grouped by updated date. So it's a good way to see the recent records that have been updated for a certain day. And the file within there is going to be in a format called JSON lines, which sounds complicated, but really it's quite simple. It's just taking, like if you're looking at API and you see a list of records, it's kind of the same thing where the example I show there is two JSON objects or two records. You just put a new line to go to the next record, and you just keep doing that over and over and over and over. Our records are set up so that once you get to, it's in parts. So once you get to 5 GB, you'll start a new record, a new file. So especially in works and other big ones, you'll start to see where it goes into the like mini parts for a certain updated date. And then it is compressed with gzip to save space. The total size of the whole snapshot compressed is 416 GB. So here's an example, just it's showing you more about what's inside the snapshot. You have your main directory of the different folders. Then you have, one of those is kind of a special one you can see on the left called merged IDs. That's going to be a subdirectory that kind of shows you how to what records we have merged together or deleted. The next folder you can see there, this is our format where you have updated date equals, and this kind of shows the, you know, how the records are grouped within there. And then you have a manifest. So there's the parts as well. So that's like 5 GB chunks of files within works for a certain updated date. And some of them can have 20, 30 parts, but it's just breaking out the data in so it's more easy to manage and download. This is what a manifest looks like. The manifest is a good way to check your data to make sure you're getting everything. And so you can see the different parts. You see the content length is kind of like counting all the characters in that file. And then the record count just shows you like the record count. And you can see there the record count, 265 million. This is literally from the last snapshot I created. So that should closely match, or be exactly what it was in the API. And you kind of see just an example of what records are being produced for different dates. So let's talk about ingesting to a database. We'll first start with talking about a relational database such as PostgreSQL. And what you're going to want to do first is download files to a local directory, or if you're working with a server, that'll be much better. But at some point, you're going to want to do that initial step and download the files into your local, a local folder, so you have them available to work with. Then you're going to go on your database, and we have examples of this in the documentation. You need to create the tables where you're going to load the data. And this is kind of just take some thought about looking and seeing like what data is it you want? Do you want all of it? Do you want parts? We have example schemas in there to say like for works kind of similar to what's in the API. So you can create that. And then the next step would be once you have your tables ready, what you want to do is run a script to convert the JSON lines into files, into CSV files. That's kind of the method we have used before, but there's others available too. You could use SQL Alchemy. You can just write a Python script or some other language that just reads the compressed data and puts it in a database row by row. There's different ways available, but this is the one we've kind of documented for people to use if you're not sure. We have a script as well that does the step of converting JSON lines into CSV files. And that is going to kind of convert in a format that PostgreSQL can understand. Once you're at that step, you'll want to use the copy command in Postgres. And if you point to those CSV files, they will just get ingested very quickly into your database tables. Now, the next way is looking at ingesting into something like a warehouse, such as Databricks. This is kind of like a lake house or whatever they call it these days. The method for this is you're going to want to copy the files to your own S3 bucket, or maybe this works to call directly to our S3 bucket, but I'm not sure if it works. I think it would, but I've never tried it. And so maybe if someone puts in the chat at some point, if they think that would work, if they've tried it, let me know. But bottom line is you're going to get the files from an S3 bucket if you're working with Databricks, not a local directory or anything like that, which is actually really convenient. Now, a gotcha when working with warehouses I found is the abstract inverted index. This is getting a little technical. The abstract inverted index is kind of not the best format. I actually want to redo that format at some point into something that works easier, but the way we set up abstract inverted index causes issues for normal ingest into something like PySpark or others, because it detects it as something like basically when you have a dictionary and you use different characters and strings, it kind of just doesn't understand it very well. So what I had to do was create a schema where I said, well, all my fields, what the types are going to be. And I'm showing you just the ID, for example, then you would have title, etc. And then I explicitly said I wanted the abstract convert index to be a certain type. And once I did that, I could see, or I could just remove abstract convert index. If I just create a schema and I ignore abstract converts, that also works. But once you do that, you're able to run this nice command down here at the bottom and point to the S3 folder and load your schema. And this is something it would run. We can run this in about an hour or 45 minutes with enough, like 5 to 10 servers running workers, and load the entire snapshot, which is really cool. So like I said, you just take the latest one, it's an S3, I'm loading it into Databricks, and I can start querying and do really complicated queries over everything. So this is the highest cost, more resources involved, but the fast way. The other way that's documented on our site is to use BigQuery. I'm not personally familiar with BigQuery as much, but we have some developers that were using it more often, and they documented how they viewed it. So that's an option as well. I've heard it works very well. It's probably something similar to this, but different command lines. And it gets it into a data warehouse that you'll be able to query probably in a faster way than in Postgres. But again, more complicated setup, more things going on, more costs compared to the good old PostgreSQL database that just always seems to get the job done and will satisfy a lot of use cases before needing this step up. So let's talk about how to keep your snapshot up to date. The first thing I wanted to mention was that, every snapshot is a full export of the entire data set. Let's see. Yeah, great, good. Let me go back. Oh, shoot. How do I go back? Oh my gosh. This is my first webinar. I'm not very good at this yet. Let's see, slideshow. Yeah, so keeping your snapshot up to date is, it's important to keep in mind that every time you get a snapshot, it is the full export. It's not a change file. It's not like just only the records that have changed since the last one or anything like that. It starts all the way at the beginning and it shows everything based on the updated dates. So some options you have when dealing with that is if you downloaded the snapshot and ingested a month ago, and you get the next snapshot and you see there's new updated dates, into the next month, what you could do is just take those new records, overwrite every ID and every record from the latest version of the snapshot using those updated dates. And then you would have, when, in kind of a lightweight way, you would have all the recent records. That's probably the way I would recommend, because then you're just going, or you could just go back however far you think you need to go back and overwrite data, and it wouldn't take very far to go back and you would have the latest data. The other option you'd have is to overwrite all the records. You could just, go through and overwrite everything and you'd be up to date. Finally, you could drop your current copy and just insert everything again. So again, you're just talking about different time constraints here of it's going to take a while to overwrite everything or to reinsert everything again if you're not using something like Databricks. But the processing new records, if you get the snapshot and you just go through and pull the latest days of each entity, like you would be up to date pretty quickly. The next thing you're going to have to handle, though, is handling merge and deletes. So what you'll likely need in your database is what we use is kind of like a merge into ID field, merge into ID field that shows when something gets merged. So sometimes records, we just realize they need to be merged together and they should be the same thing. And what we use is a merge ID for that. So there's a CSV file in the snapshot that goes all the way back to the beginning, and it shows every ID that we have merged over to new IDs. And then you can use those to merge your records together. And that's up to you if you want to track it with a column that has merge ID and you just need to know that when you look at that ID, it's been merged. Or if you want your system to be more tracking the data set better, you could actually delete your merge process could actually delete the old record and just use the new one. And that would also work. Now, something that's important to note is almost every entity has a deleted ID where if you look in the API, and this one has a little bit of a bug. I looked at this earlier and it had some extra data coming with it. But the bottom line is it's kind of like this ID is meant to be marked as a record as deleted. And so you would be able to process this wherever you see that ID, same process. You're not going to merge. You would either mark it as a merged into this ID and know it's deleted, or you could just delete it. So you could go through and follow anything that has this ID in the merged IDs CSV. You could mark those files as deleted. So that's kind of about keeping your snapshot up to date. And we do get a lot of questions about this, process and how people do it. So let's move into frequently asked questions. One of the main ones we get is, when should I use the API and when should I use a snapshot? The API can do quite a bit, and I really recommend using the API for anything under 1 million records and maybe even more. You can use something like cursor pagination and API. And if you try to run that on a fast server, you can get through the data fairly quickly. Because the snapshot has a lot of overhead and setup, and it's really built for working with everything as like on as a whole, like getting all those works in and looking at everything. So I lean towards directing people to API if they can get away with it. And then sometimes the API is just not enough, and you need more. You need more data. So then you could go ahead and use a snapshot, and once you do, you'll have a lot of other data coming with it, and you can do a lot more yourself. How big is a snapshot? It's like I said earlier, it's 416 gigabyte, but it's going to be around 2 terabyte if you need to uncompress it and convert it into those CSV files I talked about with the script. So it will get larger once you start uncompressing and working with something else, if you're going to do that. What computer specs do I need to ingest a snapshot? It's another one we hear. The hard one here, it's not really, to me, you're not so much limited on CPU or something about your computer being able to process these files. It's not too big of a job to uncompress JSON lines and convert it into CSV or things like that. What you are more likely to run into is that it's a lot of space. If you were going to do it on more of a personal computer, getting the space to uncompress the data, then load it into your database, that together is kind of duplicating the data a couple times, and you just can't, it's hard to avoid uncompressing the data, having it take up space, and then you're ingesting it in the database, and now that's taking up space. So you need a lot of free space is the bottom line if you're going to use something like a relational database and try to ingest a snapshot on your own computer. Still very doable. And if there's smarter ways to do it, you could write a Python script that just pulled directly from the compressed files and put it in a database. That would probably get the job done as well, but maybe slower. Here's another good question. Can I just download a part of the data? Like, do I have to get the whole snapshot or can I get parts? And this is a really cool thing. I think I don't know if people do enough is you can just go to the browse that website I showed you earlier, and you can just get institutions or sources, and you can just get a portion of the snapshot and work with it, or you can use AWS, but I think it's kind of just nice to browse and get the full files you want and open it and ingest it somewhere. So that's something to consider. Or if you just want to see the latest updated files or something like that, you can just download a portion. Are we ever going to create a daily snapshot? This is a big one for people that try to keep up with our API, and especially premium users that want to get data every day and stay in sync. We update our records a lot. And what happens is it's hard to keep up with through the API. And then you're waiting for this month snapshot. So we are going to create a daily snapshot. It's fairly high on our priority list. And I can't promise when it's gonna be out. Like it's not gonna be too soon, but it's on a roadmap for premium users that there will be a daily snapshot, which is pretty much like, tell me everything, give me all the records that changed yesterday in one single gzip file, likely in JSON lines, the same format. And if you want to be a premium user, you'll be able to get something like that. Next frequently asked question, I figured I'd throw in there. Is there anything you're missing in the snapshot? Well, yeah, kind of. What I would say is everything that is displayed in the API, you're getting in the snapshot. However, when you do search and you just use like the generic search and you're looking at full text, like you're not limiting to just like the title and abstract, all of that full text is in Elasticsearch and in our database. And right now we have not been exporting that in the snapshot. That's not to say that won't change. We're not against it, but that's just the way things are right now. The full text is not. So if you try to really replicate the API or what it's doing, you wouldn't have the full text that makes the search a little better. But you would have the search as title and abstract, which is often a lot and very effective. So let me see. That is all I have for working with the snapshot. I hope I was able to answer quite a few questions, and I would like to take some questions now and see what we have here. Submitted Q&A. Okay, let's see here. Yeah, first one I'm going to answer is, I think it came in. What if I don't have strong programming skill? I only use Python and R dealing with snapshots by coding. What kind of programming language do I need to learn? Yeah, that's a great question. I would say, what I would say is Python is helpful in working with the snapshot. And I don't think you can use R. You can use R and the package that some others have created to work with R, PyAlex, I think, and it works with R. Yeah, I would think the best would be to learn Python, but what would be really helpful is if you use some of these AI tools like Anthropic or others. So you learn a little bit and then you put in there, here's the format of the data I'm seeing, like work with that browser and say, how can I get this into this? It'll help you. And this is stuff AI can handle pretty well to kind of coach you along, but something to consider. Okay. And what could be the required disk size for ingesting into Postgres? Like I said, I think if you were converting it the way we recommend with CSV files, it's going to get to around 2 terabyte. And then I am not sure, maybe you're asking how big is the database size once it's in the database. I think it would be smaller in a 2 terabyte. Well, it could also be up to 2 terabytes, I would say, in Postgres once you get it in there. So yeah, so I'd say the required disk size. I wish I had time to try it. I'd love to try all this and just get some numbers and document it for everybody, or if someone ever does that, please email us, let us know, because I haven't in quite a while, I haven't like ingested data into Postgres and seen how big the database gets and things. And we use bigger databases. So I don't always see like just a single small database filled with only OpenAlex data. Yeah, hopefully that's helpful. My guess is around 4 terabyte. Is there an API to perform semantic search? Yeah, great question. We are working on that. We actually created a proof of concept for this, and we do have an endpoint that does some semantic type search already. This is I can type an answer. And let me put that in the answer real quick for you guys so you can check some of it out. It is called, where is it? Aboutness endpoint. Let's see, aboutness, keywords, topics, concepts. Yeah, I guess it's not completely similar. This is some stuff we can work on, but yes, we are working on semantic search is not available right now. It's on our roadmap, and we have gone through a project where we converted the works, the title and abstract and everything, sent it to OpenAI to get embeddings, and then we stored all the embeddings and we're able to do semantic search. We just haven't had the resources to fully release it lately, and it hasn't been the highest priority to support it so it works in production like we want it to work. So that's what we're working on next. Um, but yeah, semantic search will be, and one feature we are really excited about is we want to take semantic search and build aboutness of authors and other things and journals and be able to say, says author made these, wrote these 50 articles, and these are the embeddings, and then you can merge those embeddings together to give yourself to create an aboutness of that author. And you could do things like find co-authors or find authors to for peer review and things like that because they're related, but not having to search by keyword and things like that. Is there any instruction video to show practically how to get the snapshot and inquire about the data from the snapshot? Not that I'm aware of right now, but I'll take that back to the team and see if that's something we can work on. What is the best way to ingest the data into a local Elasticsearch cluster? That's a good, you know what I would recommend is if I would recommend spinning up a local Elasticsearch cluster with Logstash. And then I believe you could point at the records and pull it in via something like a Logstash fairly quickly and pull the data into Elasticsearch. We do have, it's another one of those you kind of need to, well, you don't have to make a schema. We make a schema ahead of time. And what we do is we run after the data is in a database, we run it over and directly send it straight from the database into Elasticsearch. But you could definitely call all those files with something like Logstash or with Python. There's good Elasticsearch tools in Python. There's Elasticsearch package that you could just go over all those JSON lines files and ingest it. Logstash should probably be the fastest, but Python Elasticsearch package would work really well too. And I love Elasticsearch. It's amazing, everything it can do. So yeah, super helpful. That was answered live. Okay. Got that one. All right, do we have any other questions? All right, we don't have any other questions right now. I hope this was helpful. We are recording it. I think we'll post this later if you want to come back to it. And yeah, feel free to email me at casey@rresearch.org or our support at openalex.org if you have other questions or something I didn't cover well. If you'd like some more help, I'd be happy to help people that attend the webinar and see if I can help you with something. Thanks everybody, and I hope you have a good day.